Good day, everyone. Today, we'll be discussing topics for Unit 2, components of PLC for our subject, ESD3, Programmable Logic Controller. In Unit 2, we'll be discussing the components of PLC that would include the processor, the input-outputs module, the memory circuits, the power supply, and the programming terminal. After this lesson, we expect that the students must have first determined the operational circuit of the PLC, CPU, describe the importance of addressing the input and output module, discuss how the input-output is used in PLC programming, explain the purpose of data input-output interfaces, and describe the importance of power supply. The PLC has actually five number of components, which sometimes not incorporated in the PLC itself. Just like this programming device. Actually, a programming device is a computer, which is not actually part of the PLC system itself. I mean, the PLC itself. This is usually a computer wherein we program the PLC using this device. And from the computer, we upload or download programs, either from computer to your PLC or from your PLC to your computer. Then the major part of the PLC is the central processing unit. Another is the input and output section, which consists of the digital and the analog input output, the memory, then the power supply. We will discuss first here the central processing unit. The central processing unit, or the CPU and PLC, is responsible for updating inputs and outputs. It is also responsible for communicating with memory, scanning the application program, communicating with programming terminal. These are the function of the PLC. A PLC CPU is controlled by operating system software. The operating system software is a group of supervisory programs that are loaded and stored permanently in the PLC memory by a PLC programmer. For the structure of the PLC, programming terminal here is external. We have here the PLC itself that would include the power supply, the CPU, the memory, the input module, and the output module. External are your input devices, as the switches. External also is your output devices that usually motors, lights, and other type of electrical loads being controlled by your PLC. How a PLC would work. In this diagram, you could see here switches. Actually, switches here are external. That is connected to your input module being sent to your processor or the central processing unit, responsible for processing the signal coming from your input module, and sent. The CPU sent signal to your output device or output module, and the output module usually is connected with the external device, which is your load. In our example here, the lamp. Actually, you know how it works. A PLC check first the input. It scans the input, then pass the program to your CPU. So your CPU, what we call here, we have what we call the program scan. A program scan is the program, it scans the program you have loaded to your PLC. Then out from the program, it produces an output. So the output here produce or switch on the load so that it either turns or off the load circuit. This is being repeated every millisecond. So how fast is this? The time to complete the cycle is what we call the PLC scan cycle. A PLC performs scan sequentially and cyclically. In our example here, it checks the input, check the program instruction, execute the program, read the last program instruction, and again, produces an output, check input, run the first program, run the next program, check the last program, then produce an output. This is a cycle. Cycle meaning it doesn't stop, no? It is a loop. Then sequential is by sequence. First instruction, second instruction, third instruction up to the last program instruction. Usually it is made within terms of millisecond. In our example here, we have 10 milliseconds, and we do understand that 1 second is equivalent to 1000 milliseconds. Memory. The part of the PLC memory is where the data or the information are being stored. We have the two major parts of the memory circuits. We have the ROM or the read-only memory, and we have also the RAM, which is the random access memory. The ROM usually records the operating software used by the PLC, while the RAM stores the program being created by a programmer. Memory are being expressed in terms of kilobytes, bytes, or bits. No? So if you talk about bytes, 1 byte is equivalent to 8 bits. 1 bit is either a state of 1 or 0, or in common language, it is either state on or off. PLC memory mapping and input-output addressing. When we do programs, usually we define memory, we define the address which is being stored in the memory. So if it is an input, we need to define which input we want to use and which output we want to use. It is being interpreted or it is being made based on your connections. So you create a program based on the connections of your PLC. How to control it is now the work of your program. That is why it is necessary that correct addressing is made. No? So you should have to define which is the input, what is the address of that input, and which output we want to have the output. And we must also observe correct addressing. So we'll discuss addressing when we do now programming. So the association between input, output points, and memory location by no means standardized between different PLC manufacturers or even between different PLC models designed by the same manufacturer, meaning there is no standard, but the system is just like quite the same, but the method of writing or how they are going to identify the address is dependent on the type of manufacturer and the type of PLC you are using. This is why it makes it difficult to write a general tutorial on PLC addressing, and so my ultimate advice is to consult the engineering references for PLC systems you intend to program. Actually, this is just simple. No? If you learn the basic of programming a PLC, you can do it in different types of PLC. No? There is a slight changes no, in programming. Actually, the circuits are the same. It is just a matter how are you going to program, and it depends on the type of software or window we are using. When you say here window, no, the desk or the the guide in a computer where we are going to do the programming, because it varies in the different types of the manufacturer and the types of PLC we are using. But of course, the circuits and how it is being programmed are just likely to be the same. So if you have learned programming from one type of PLC, you could do programming in different types of PLC with a slight changes, meaning you could really program a different types of PLC, with just a little review of the topics you learn from PLC programming. A PLC actually looks like this. No? It has an inputs and it has an output. This is labeled. No? This is what we call the address. We need to address no x1, that is input 1. We need to address no output 1, that is y1. So there are several methods of labeling this one, no, in the type, depending on the type of the factor. Sometimes we use x, sometimes we use I for the inputs, and sometimes they use q for the output, and here's why y. No? Actually, those are just labeling. This type of PLC is what we call monolithic PLC, meaning it has a fixed, sorry, it has a fixed number of inputs and a fixed number of output. Usually, a PLC, we provide inputs, no? And here are examples of your input devices. We have classified this into digital and analog. For digital inputs, we have switches, push buttons, and sensors. Usually, we produce voltage for this, no? In either two states, no? Either on or off, because digital either talks about on or off, 1 or 0, true or false. In analog, we talk about levels, no? How much is the value of voltage? We from 0 to 12 or 0 to 5? 0 to 5, meaning when we say 0 to 5, we have 1, 2, 3, and 4. For the distance, how many meters? No? And for velocity, as well as voltage, no? Voltage levels, either 1, 2, 3, and 4, or 5, or either no? Up to 5 volts. These are analog, meaning it varies. Unlike this one, digital, there's only two states, either on or off. For the output devices, which we tend to switch on or off, now we have examples. We have the actuators, we have solenoid bulbs, relay contacts, motors, bulbs, signal devices, and others. For the types of PLC, again, now we have discussed, I have introduced to you the monolithic, and we have also the rack type. What is the difference between a rack type and a monolithic PLC? In a rack type PLC, we could easily replace cards, meaning we can place an input card and we can replace that using an output card. So it is a plug-in type. So we can, using the rack, we could add more inputs and more outputs on a PLC itself. So usually it depends on the type of manufacturer and the type of PLC we are using. Rack type, stackable, we could increase the number of inputs and we could increase the number of outputs. Unlike in the fixed type that the number of inputs and outputs are specified. We could also connect PLC into networks, wherein we have the host PLC and we have the remote PLC. We could connect many PLCs now if we want to, or if we need to have several control systems. Now we need to monitor several inputs and we have to produce several outputs. We can connect PLC and networks by simply using a wire, or in this new era, they are now using even the internet. Programming terminal. When we do programming in a PLC, we need this device na a computer wherein we load the program here, dependent on the type of PLC. Then we do the program in the computer and upload the program to your PLC. So we do hardware connection in your PLC. We provide inputs. We produce outputs that will drive motors and other types of loads. And the control of programs, how the systems behave, is dependent on the program you created in your programming terminal. That is why in a PLC system, you don't need really to change the hardware programs, the hardware connections, but you could change the actions of your system by simply changing the program in your computer and upload that to your PLC. And it is easy to change the program than to change the wiring connection. This is the most advantage of PLC over relays and other connections. Now, because of PLC, you don't need to change the connections, but you only need to change the program, to revise the program so that the actions or the functions of your system would change dependent on the program you have created. If we want to select the PLC or what type of PLC we're using in our applications, we have to consider the following. the number of logical input and outputs. So we could determine that based on the requirement of our projects or circuits we're going to use. The memory, the number of the special inputs and outputs if you need it. The scan time. The scan time is the runtime or how fast it would read the entire program made in your PLC. The communication, how are you going to connect your PLC from one device to another device? Communication, ways of communication, either wireless or either network or either cable. Then we have here the software. So each PLC has its own dedicated software for use for programming. There are software that are free and there are software that are being paid, no, through registrations, and that's quite a lot of money, dependent on the use of your PLC. In our study, no, we will be using this Omron Micro PLC, just like this one, because this type of PLC, you could download the software for free, and for practice purposes, we can use this one. So it consists usually of 6 IOs. No, no, no. 10 IOs, we have 6 inputs and 10 outputs. Actually, the outputs here are just switches and the inputs here are being connected to the switches. So we'll discuss more on this and during our next lessons. So for now, thank you very much and have a good day, everyone.